Okay, here's the third lecture in the Module 5, Compilation, Lexing and Parsing. And we were talking about ambiguity in parsing trees. So again, here I'm showing the two different parse trees for the string left paren, left paren, right paren, right paren, left paren, right paren. We're going to change this to a non-ambiguous grammar. In fact, we're going to use a completely different grammar for the example of how bottom-up parsing works, but the idea is you start with the leaves and the parser keeps taking the symbols and adding them to the stack. It is a stack machine, just like we studied in Module 3. And the technique is called shift-reduce parsing, and the reason is if you can't change anything, if you can't use a rule backwards, you shift the symbol or the token onto the stack, and then once you find that you can use a rule, you reduce the stack. So for example, we take left paren. Can I find a rule that has only a left paren? No. Another left paren. Can I find a rule that has two left parens? No. Left paren, right paren. Now, can I find a rule that has left paren, right paren? Yes. That would be left paren, right paren gets replaced by P, so I can take these two symbols and replace them with a P. That's a reduction in what's on the stack, so it's reducing. So we shifted a left paren, shifted a left paren, shifted a right paren, and then reduced to P. Then when we see this next right paren, we say, okay, left paren, P, right paren. We shift that right paren on the stack. Left paren, P, right paren. Oh, we have a rule for that. That's this rule over here. That gets reduced to a P. So we reduce all those things to P. And so what's happening is as you reduce, you're going up the parse tree or up the syntax tree. So there's a particular author that has a good example of this, and I've given the link to the text at the end of the notes here. But it's called shift-reduce parsing. Sometimes it's called LR parsing, left to right parsing, because we're taking the strings left to right. So this is a very common scheme. We use the rules left to right, the tokens are shifted onto the stack, and every time we can find we can use a rule backwards, we reduce, and we're moving up the parse tree. Now this next slide, I'm warning you, it's a very busy slide, but let's walk through it. Here's the grammar that the author's using. This is Sebesta. And it's basically a form of an expression language, meaning that it creates mathematical expressions. So they say expression goes to expression plus term, expression can go to term, term can go to term plus, I don't know what F stands for, or term can just go to F, F goes to an expression inside parentheses, so he gets nested parentheses, or F can just go to ID. Now remember, I was calling that var earlier, this author is using ID. And the string that they want to parse is ID plus ID times ID, and they use $ as end of stack or bottom of stack. And the goal here is if they get to bottom of stack at the same time they can produce the start symbol, that's a legitimate string. And they use this table over here. This tabular form is basically the delta function, but it's the delta function backwards. These don't help me. These are the states that the machine has. These are the symbols that you might push onto the stack, and then when you reduce, you can go to other states. And until you get the hang of how to read this table, it is a little confusing. They start out with a 0 on the stack. That's going to effectively be their start symbol. They're saying they're in state 0. And they see the string that they still have to parse is ID plus ID times ID. And so they're in state 0 and they shift an ID onto the stack. Well, if you're in state 0 and you see an ID, it says to shift 5. That means shift ID onto the stack and go down here to state 5. And that's represented on the stack as 0 ID 5. Then they see a plus sign and they say, okay, so if you see a plus sign, I'm in state 5 and I see a plus sign, it's R6. That means reduce using rule 6. Rule 6 backwards says ID gets replaced by an F. So they pop the ID 5 off the stack and they put an F on the stack, but notice they're putting that F on the stack, and they have 0 over here. Now they've removed ID 5, so 0 is on the stack. That means they're in state 0, and they're gonna shift an F onto the stack. So 0 F says to go to state 3. So that's why it's 0 F3. They've got an F on the stack, and they're currently in state 3. In state 3, they see a plus sign, and state 3 plus sign says reduce 4. What is rule 4? Oh, if I use rule 4 backwards, that F gets replaced by a T. So I remove the F and the 3. Now I'm again 0, shifting a T. So state 0, shifting a T. I go to state 2. So sure enough, it says 0T2 on the stack. And now I still see the plus sign. So if I'm in state 2, a plus sign says R2. Reduce using rule 2. Oh, rule 2 backwards says the T gets replaced by an E. So I'm removing the T0, the T2. I have a 0 on the stack. If I have a 0 on the stack and I push an E onto the stack, the table says to go to state 1. So here I am at 0E1. I still have the plus sign on that I haven't yet consumed. So now I'm in state 1. I see a plus sign and it says, go to shift and go to state 6. So now I shifted the plus sign onto the stack and I'm in state 6. I see an ID. State 6 with ID says to shift and go to state 5. So now I'm at 0E1 plus sign, state 6, ID 5. I see the multiplication sign. State 5 with a multiplication sign says, oh wait, reduce using rule 6. And what are we going to do? We're going to get rid of that ID again and replace it with an F. So if I get rid of the ID, I'm pulling ID 5 off the stack. That means that the state 6 is the thing that's laid bare. And I'm pushing an F onto the stack. Let's see. Whoa, don't help me. So here I am in state 6, pushing an F onto the stack. And in state 6, if I push an F onto the stack, I go to state 3, so that's why it's 6F3. I still see the multiplication sign. State 3 multiplication sign says reduce using rule 4. Rule 4 backwards says replace the F with a T. So now I'm going to go and remove this F3, and I'm in 6, state 6, right? The 6 is exposed. When I remove the F3, the 6 is exposed. And I take rule 6, pushing a T, state 6, pushing a T. Let's see, state 6, pushing a T says go to state 9, so that's why it's 6T9 at the end. With 9, if I see the multiplication sign, 9, multiplication sign says shift 7, so I shift the multiplication sign onto the stack, and now I'm in state 7. Now I'm looking at ID. State 7, ID says shift 5, so state 7, ID says shift 5, so now I've got 7 ID 5, and now I'm looking at the dollar sign, end of string symbol basically. And if I'm in state 5, dollar sign says reduce using rule 6. Well, that means the ID gets turned into an F. ID gets turned into an F. I've pulled the ID and the 5 off the stack, so the 7 is exposed. And state 7, if I push the F onto the stack, I look at 7, F goes to state 10. State 10, dollar sign says reduce using rule 3. That means this whole expression, T star F, gets reduced to T. So we're going to remove T star F. If we remove T star F, that goes all the way back to state 6. And I'm replacing T star F with T. So if I'm in state 6 and I push a T onto the state, I'm in state 9, and sure enough, 6T9 is on the stack. I see the dollar sign. $9 says reduce using Rule 1. Rule 1 says E plus T, there it is, E plus T gets replaced with an E. So E plus T is going to get replaced with an E, but since I removed E plus T, I'm in state 0. That 0 was exposed, and 0, E says to go to state 1, so 0E1. Now I'm in state 1, I see a $sign, state 1, $sign, accept. All of that just to show that ID plus ID star ID is actually in the language. Now, how do you create this table? You don't. That's what software is for. Software will create the table. Now, here's the link, by the way, in this small print down on the bottom of the slide. All right, so what's happening is this is giving you this sequential step of how to use this, how this table gets used to parse the string. And remember, we like graphical forms as humans, but computers love tabular forms. All right, let's walk through this briefly one more time. I'm going to be very brief here. If I drew the syntax tree for this, it's ID plus ID times ID. And if you notice what happens when we see that first ID, what happens? The ID gets replaced by an F, the F gets replaced by a T, the T gets replaced by an E. Oh, stop helping me. I don't know how to turn that off. But look what's happening. ID gets replaced with an F, F gets replaced by a T, T gets replaced by an E. We're working our way up the parse tree. Then we get the... If I wasn't being recorded, you would be hearing a lot of cussing right now. So I've got that E, then I get E and the plus sign gets in there. That's equivalent to looking at the parse tree and saying E plus. Is there a rule in E, just E plus, that I can use backwards? No, I need E plus T. But I don't get E plus T, I get E plus, and the next thing on the stack is ID. But look at what happens. E plus ID, that ID gets replaced by an F, the F gets replaced by a T. So that's going up the tree again. This ID gets replaced by an F, which gets replaced by a T. And then I put the star on there in the other ID. That ID gets replaced by an F, ID gets replaced by an F, and then T star F gets replaced with T. We're working our way up the parse tree. And then E plus T, finally, E plus T gets replaced by E. And so that's why we end up with an E on the stack. Oh, and we're out of string. We're out of string, and we produce the start symbol. In this case, it's the E. And that means the string gets accepted. So the table is a little confusing until you get used to working with it. But hopefully you can see by the behavior of the parse tree what's happening. You're taking these leaves and walking your way up the parse tree. And walking your way up the parse tree. So all the IDs get replaced. This ID gets replaced with a T, this ID gets replaced with an F. Now I've got T star F, which can be reduced to a T. Now I've got E plus T, which can be reduced to an E. And that string is considered valid within the language. I think the parse tree explanation is a little more clear than the table, but the table is just performing those actions and representing them in a way that computers can handle. Computers love lookup tables. They don't like graphs. Humans love graphs. So that's what's happening. We'll go over this in the live lecture on Wednesday also.